When lightning strikes, it seems almost as though the sky itself is on fire. These gigantic sparks are actually some of the most powerful bolts of electricity on Earth. But how do they get that way? How does lightning create so much power? First, we need to look at what's happening up in the clouds. Storm clouds are like big factories that produce tons of static electricity. The top of these clouds become positively charged while the bottoms become negatively charged. It is kind of like when you rub a balloon against your hair and it sticks to the wall. Except with clouds, there's a lot more charge being generated, and it's separated into distinct areas. As the positively charged top of the cloud brushes up against the negatively charged bottom, the two charges start to attract each other. Eventually, the attraction is strong enough to overcome the insulating properties of air, and the charge jumps through the air from one region to the other. This sudden movement of electricity is what we see as lightning. But why does it produce so much power? To answer that, let's look at a single bolt of lightning. During a lightning strike, electrons move extremely quickly through the air. Since air molecules are mostly made of oxygen and nitrogen, which are gases, the electrons collide with those molecules, knocking them over like dominoes. The air molecules get pushed out of the way very fast, creating a shock wave that expands rapidly. This expansion causes the air to explode outward from the lightning bolt. And because it happens so fast, it makes a loud noise that we hear as thunder. But back to our original question, where does all this energy come from? Why does lightning have so much power? Well, during a lightning strike, a huge amount of electrical potential energy is converted into heat. That's why lightning is so bright. It's not actually flames, but heated air molecules that emit light before they explode. The temperature of a lightning bolt can reach 30,000 degrees Celsius. That's about 18,000 degrees hotter than the surface of the sun. All that heat is produced in a channel of air that's only about half an inch wide. If we could capture it, just one strike could power a small town for an entire day. So why don't we harness this energy? Unfortunately, lightning is extremely unpredictable, and by the time we figure out where it's going to strike, it's too late. Plus, capturing lightning would require technology that we haven't developed yet. But even without our help, lightning bolts follow a fascinating path. When a bolt of lightning first forms, it moves through the air like a huge whip. At the end of the whip is a glowing blue tip called a streamer. The streamer moves toward the ground at a speed of up to 186,000 kilometers per hour. That's more than 10 times faster than a speeding bullet. As the streamer approaches the ground, smaller branches of lightning called photons reach out from the ground to meet it. When the photon connects with the streamer, a channel is formed between the cloud and the ground. Electrons then flow through this channel, creating a complete circuit. It's like a giant battery that discharges all at once. Lightning comes in many shapes and sizes. Some bolts are jagged and white, while others are forked and blue. Sometimes lightning occurs in circles or even diamonds. But no matter what form it takes, lightning always follows the path of least resistance. It seeks out the easiest way to connect with the ground and discharge its electricity. In some cases, the path of least resistance is through water. When lightning strikes water, it creates a bright flash and a loud crack. This can happen on the surface of a lake or ocean, but it can also happen underwater. In fact, lightning is one of the main ways that deep ocean water gets its electricity. The constant bombardment of cosmic rays creates a layer of charged particles in the upper atmosphere. When these particles reach the ocean, they cause a chemical reaction that produces a bolt of lightning. Lightning is one of the most spectacular displays of nature's power. It shows us the raw, unstoppable force that can be unleashed when electricity surges through the air.